As scientists continue to explore the vast expanse of the universe, they've made some incredible discoveries that have left them with more questions than answers. From a scorching super-Earth to a football-shaped world, the exoplanet discoveries of 2022 are truly out of this world. So hold on tight, the future of exoplanet discoveries is looking brighter than ever. Number 1. New type of exoplanets. Red dwarfs make up over 70% of all stars in space. So, in September of 2022, scientists decided to take a closer look at the small worlds orbiting them. What they found was amazing. New type of exoplanets that were made of half rock and half water, either in liquid or ice form. The researchers suggested that these planets likely arose from icy material and were born far away from their stars, past the ice line, where surface temperatures are freezing. But they later migrated closer in, to where the astronomers detected them. This discovery could have huge implications in the search for life in the cosmos. Though these planets are loaded with water, they might not be covered in oceans. Who knows? Maybe one of them will be the next Earth 2.0. Number 2. Jupiter-sized world. Imagine a planet so massive and mysterious, it's like a hidden Jupiter in our galaxy. Well, we just discovered one of those orbiting a star just 379 light-years away. Just. We've named it the TOI 2180b, and it's got everyone talking. Why? Well, for starters, this planet takes a whopping 261 days to orbit its star, which is much longer than most distant gas giants we've come across so far. But that's not all. The temperature on this world is surprisingly mild, averaging at a balmy 170 degrees Fahrenheit. For a comparison, the temperature on Jupiter and Saturn is around minus 280 degrees. It's like a bridge between the giant exoplanets we've found and our Jupiter. But the question remains, how did this planet get to be so different? Scientists are still trying to figure that out. Let's hope that we get some answers soon. Number 3. The Hulk planet. This world is a place where the surface is covered in molten magma, and the year lasts just half a day. Welcome to TOI 1075b, an exoplanet that's been dubbed the planet Hulk by scientists. Located 200 light-years away, this super-Earth is one of the most massive ever discovered. Its proximity to its parent star causes its surface to reach scorching temperatures of 1922 degrees. It's so hot that any form of water would evaporate instantly, and the air would be filled with vaporized rock. But it's not just the heat that's impressive, it's also its size. TOI 1075b is nearly 10 times the mass of Earth, making it one of the most massive super-Earths ever discovered. But the mystery doesn't stop there. The planet's orbit takes just 14.5 hours, making it one of the shortest orbital periods ever recorded for a planet of its size. What an exciting addition to our catalog! Number 4. 3 doomed planets. Astronomers made a shocking discovery of 3 planets that are circling in a dangerous dance next to the slowly fading stars. Just a decade ago, scientists never even imagined such planets could exist. These gas giant planets, similar in size to Jupiter, orbit way too close to their slowly fading stars. They're basically walking on the edge. Take one of them, for example, dubbed TOI 2337b. Its orbit will likely send it hurtling straight into the fiery arms of its host star in less than 1 million years. Well, I won't be around then. As these stars enter their final days, they're pulling in nearby planets like a black hole, altering their orbits and potentially causing catastrophic collisions. And as these planets get closer to their stars, their atmospheres heat up and swell, leading to some mind-boggling differences in density. But despite the doom and gloom, studying these worlds could give us valuable insights into the evolution of our own solar system. Number 5. Planet with a barium's atmosphere. These are 2 hot blazing planets, each with an atmosphere made of the heaviest element ever found in an exoplanet, barium. These planets, known as WASP-76b and WASP-121b, are ultra-hot gas giants called super-Jupiters that orbit incredibly close to their stars. These planets are basically like giant balls of fire, with one side facing the star, cooking at temperatures hot enough to vaporize iron and other metals. But as the hot iron vapor is blown into the planet's cooler night side, it turns into liquid and falls as iron rain. And these planets held a special surprise for us. Barium is a heavy metal, about 2.5 times as heavy as iron. And yet, scientists were able to detect it in the upper layers of these planets' atmospheres. This is truly a mystery, and a puzzle we're still trying to solve. Imagine landing on a planet like this and looking at this rain of iron and the heavy barium in its skies. That would be awesomely horrifying. Number 6. The Football Planet. Get ready to have your mind blown, space enthusiasts, because we've just discovered the ultimate football-shaped planet, and it's unlike anything we've ever seen before. Meet WASP 103b, the ultra-hot exoplanet that's more than 1,000 light-years away from Earth. This gas giant is so close to its parent star that its shape is being stretched by the intense gravitational forces. But this isn't just a fun shapeshifter. It's also a valuable scientific discovery. By studying the planet's passes across its star, we were able to measure its deformation for the first time ever. It's like taking a snapshot of a planet in motion, and it's giving us insights into the extreme conditions that these planets can endure. This is truly a great discovery. Number 7. A zodiacal light. Are you ready for a cosmic ghost story? Scientists and high school students in China have uncovered a spooky phenomenon on 3 distant exoplanets. It's called zodiacal light, a glow that's similar to the one seen here on Earth during sunset. But this isn't just some eerie light show. It could hold clues about the makeup of these potentially habitable worlds. Imagine watching the sunset from a dark spot on Earth, and instead of darkness, a triangle of light appears. That's zodiacal light. It's caused by sunlight reflecting off dust particles that fill the solar system, the remains of asteroids and comets. A team of researchers analyzed 47 potential habitable exoplanets named Kepler 69c, Kepler 1229b, and Kepler 395c, all super-Earths, had signs of this light. This discovery is more than just a spooky phenomenon. It could reveal information about the presence of asteroids and comets in these exoplanet systems, which could be difficult to detect otherwise. So that's pretty neat. Number 8. A planet with silicate clouds. Introducing VHS 1259b. Not a home video recording system, but a strange and exotic world shrouded in mystery and wonder. A place where the clouds are made of sand and the sky is forever red. This isn't the stuff of science fiction, but a real-life discovery made by the brilliant minds at NASA. This is a brown dwarf exoplanet that's making waves in the astronomical community. It's way too massive for a planet, nearly 20 times the size of Jupiter, but it's not quite a star. It's something in between, a cosmic enigma that defies definition. But what's really crazy about VHS 1256b is its atmosphere. Scientists have discovered that this strange world is cloaked in thick clouds of silicate grains, similar to sand. It's the first time this kind of cloud has ever been detected on an exoplanet, and it's a discovery that's sure to change the way we think about the universe and the possibilities of life beyond our world. And there you have it, folks. The year 2022 was filled with incredible discoveries and groundbreaking findings in the world of exoplanets. But this is just the beginning, as scientists and researchers continue to explore the vast expanse of space. We can only imagine what other wonders await us. So, let's keep looking. Who knows what secrets the stars hold for us next? Now, Jupiter used to be flat and look like an M&M candy. Now I'm hungry. And it wasn't the only flat pattern in our solar system. Turns out there are tons of things that can go wrong during a planet's formation, like locking up to the sun or getting whooshed into open space. Let's check it out. The Earth isn't flat, but Jupiter might have been. Instead of being a big round ball, gas giants in our system might have started more like flat pancakes. Jupiter is one of the oldest of our neighbors. It's 4.6 billion years old, just like our Sun. And when it was just a baby planet, it likely formed through a process called disk instability. It all begins with stars. When a star is forming, it doesn't look like a round object. It's more like a big disk of stuff. During this stage, really hot winds made of charged particles blow out. The dust in that disk contains stuff like carbon and iron. Some of them collide and stick together, forming bigger objects. Dust turns into pebbles, pebbles turn into rocks, and rocks bump into each other, getting bigger. Gas in the disks helps all these solid bits stick together. Some break apart, but others stick around, and they're the ones that become the basic pieces of planets. They're called planetesimals. Even gas giants like Jupiter started off as tiny specks of dust, smaller than a human hair. Eventually, they formed their own big ring-shaped disks of gas. They began to spin around our sun, growing bigger by gathering gas and rocks like snowballs. Gas giants are special. They were born from the colder parts of the disk. In cold areas, molecules are slower, which makes them easier to grab. In these places, water could freeze, and tiny ice pieces stick together and are mixed with dust. These dirty snowballs gather up and then form cores of huge planets, like Jupiter, Saturn, Uranus, and Neptune. In the warmer areas closer to the star, rocky planets like Mercury, Venus, Earth, and Mars start to form. After the icy giants were born, there wasn't much gas left for these smaller planets. It might take tens of millions of years for these rocky planets to form after the star is born. And our sun was growing at the same time, sucking up nearby gas and pushing faraway stuff even farther out. After billions of years, the disk changed completely, turning into a round star with a bunch of planets, dwarf planets, asteroids, moons, meteoroids, and comets around it. Recently, simulations showed that these protoplanets, as these early dust balls are called, don't start off looking like the planets we know. In the case of gas giants like Jupiter, they look more like squashed balls or M&M's candies, not the peanut kind. When the sun was young, the disk of gas and dust surrounding it cooled down and became unstable. It started breaking into big chunks. These chunks dramatically collapsed together under huge gravity to create Jupiter. It became a round gas giant over time. There are a lot of oddities that can happen during that process of planet formation. Ever wonder why Venus or Uranus spin in the opposite way compared to other planets? Usually, when things form from a spinning disk of gas, they tend to spin in the same direction. For example, if you spin a bunch of balls on a string, they all twirl in the same way. So, theoretically, all planets should spin in the same direction too. But there are a lot of fast-moving objects like comets and asteroids in our solar system. When they smash into planets, especially during their early days, this collision might send the planets to spin in the opposite direction. Venus and Uranus probably survived a massive collision. Luckily, they weren't repelled to outer space. The gravity from the Sun and nearby planets pulled them back into place. There are also so-called tidally locked planets. These are celestial bodies that spin in a way where one side always faces their star while the other side remains in perpetual darkness. So one side is always very hot while the other is extremely cold. If we were on a planet like that, we would only be able to live on a thin line in between. These planets form when they're very close to their star. The gravitational forces are extremely strong, and over time, these forces slow down the planet's rotation until it matches the time it takes to orbit the star. Imagine you're spinning in your chair. Someone comes up to you and, holding onto your chair with their hands, starts spinning with you. This way, you'll always face each other. Tidally locked planets kind of work like that. Our moon is tidally locked to our Earth, which is why we only see one side of it. We've discovered more than 5,000 planets outside of our solar system called exoplanets. Some of them have very strange orbits. For example, planets with incredibly long orbits, thousands of years to make one trip around the star, or very wonky, comet-like orbits, or so-called hot Jupiters. They're super close to their star, way closer than Mercury is to our Sun. But these planets couldn't have formed where they are now. As their solar system evolved, they changed their positions for some reason. This rearranging is called planetary migration. There are three main ways this migration happens. First, because of the gas and dust spinning around the planet. When a planet is bumping into this stuff, it can create spiral patterns in the gas. These patterns can either push the planet closer to the center or farther away, depending on how they mix together. It's called a gas-driven migration. This is what Jupiter experienced when it moved closer to the Sun billions of years ago. I wasn't around then. This also explains the existence of hot Jupiters. Second, big planets can shove the smaller ones, changing their paths. Third, the star's gravity can tug on the planet, making its orbit more circular. Ever heard of rogue planets? Imagine a lonely planet floating in the vastness of space without a star to call home. They're like the wandering nomads of our galaxy, doomed to drift around forever. And there are so many of them, there might be more free-floating planets than ones that are tied to stars. We're talking trillions of rogue planets hanging out in our Milky Way galaxy alone. They're often as massive as our biggest planet, Jupiter, but most of them might be Earth-sized. Some might even have thick atmospheres that keep them warm, even though they're far from any star. Some of them might have wild auroras, while others could host moons with liquid water, a potential haven for life. There's even a chance that they might contain extraterrestrial life. These planets might bump into other stars or even entire planetary systems as they journey through space. Sometimes they might get caught in a star's gravity for a while before getting flung back out into space. But how are they born? Sometimes, during this chaotic process of planet formation, not all planets can manage to stay close to their parent stars. Some of them get kicked out of their solar systems due to powerful gravitational interactions with other planets or passing stars. These ejected planets become rogue planets. In 2012, astronomers found a solar system from the very beginning of the universe. This system included a star and two planets. We called it a fossil system. The star is super old, about 13 billion years, almost as old as our entire universe. It was mostly made of just hydrogen and helium. This is unusual because planets usually form from clouds of gas that contain heavier stuff. That's when we figured out that the way planets formed before was different from how they form now. We know that stars with more metals are more likely to have planets. In astronomy lingo, metals means any chemical element other than hydrogen and helium. But in the early universe, there weren't many metals. Most of them were created inside stars and then spread out into space when those stars blew up. So, when did the very first planets form? This newly discovered system helps answer these questions. Its two giant planets are orbiting a star that's incredibly low in metals and extremely old. This should be really rare, if not impossible, but they exist. This means that maybe there are more planets in metal-poor systems than we thought. Studying them will help us learn more about the history of planet formation.
Have you ever wondered why all planets are perfectly round? And what if these celestial bodies decided to break the rules and change their shape? Would we end up with square planets, triangular moons, or maybe even intergalactic shapes we can't even imagine? Well, let's find out. So how do planets form in the first place? The universe is filled with swirling clouds of dust and gas. These clouds, called molecular clouds, consist of various elements and compounds such as hydrogen, helium, carbon, oxygen, and so on. They're like a cosmic kitchen filled with the ingredients needed to cook up some brand new planets. The first step in the recipe for planetary formation is called the accretion theory. Let's say that something happens that causes gravitational instability, like a supernova goes off nearby or something. This pushes the gas and dust in the cloud and causes them to come together. Because of gravity, these particles start falling toward a central point. They become more tightly packed together, like when you squeeze a ball in your hand. And eventually, they're squeezed so hard that the cloud starts to flatten into a disc shape, kind of like when you mix flour and water to make pizza dough. This disk is called a protoplanetary disk. It's also spinning because the cloud's particles had some rotation to begin with. Now, imagine these tiny dust particles and gas molecules dancing around in the disk. Sometimes they bump into each other, and when they do, they stick together like Velcro. These little clumps of dust and gas are called planetesimals. They're the building blocks of planets. And as the planetesimals continued to collide and merge, they grew larger and larger, forming protoplanets. The protoplanets were getting serious about their size, and their gravity became stronger. Some of them got so massive that they became the grand masters of their cosmic neighborhoods, the planets we know and love. Each planet had its own unique recipe of gases, rocks, and sometimes even water. But why do the planets look like spheres? Well, it's all because of gravity. Let's go back to our protoplanets. Imagine you're squeezing a balloon with your hands. The air inside of the balloon pushes back, creating pressure. Something similar happens with planets. Gravity squeezes its material inward, pulling in towards the center. And since gravity acts equally in all directions, it pulls material from all sides toward the center of mass, resulting in a sphere-like shape. And that material pushes back with pressure, resisting the force of gravity. In the end, they both find a sweet spot where they balance each other out. It's called hydrostatic equilibrium, a fancy term that means everything inside a planet is in balance. But that's not all. Another thing that makes the planet spherical is their rotation. Think about a ball of Play-Doh or something like that. Imagine you spin it rapidly. The material starts to push outward, making the Play-Doh bulge at the equator and flatten at the poles. The same thing happens to planets. As they spin on their axes, the combination of gravity and rotation pushes the material outward, making the planet bulge at the equator. They low-key want to become disks again. However, gravity doesn't want any lumpy planets. It wants them to be nice and round, so it keeps pulling on the material, trying to make everything as compact as possible. Eventually, gravity wins, and the planet settles into a spherical shape. Let's take some examples from our planetary playlist. Jupiter, the giant of the solar system, loves to show off its oblateness. It spins so fast that it becomes noticeably squished at the poles and chubby in the middle. It's like a spinning top with a cute belly. Saturn, the ringed wonder, also joins the oblate party. It spins around with its beautiful rings, and its oblateness is even more pronounced than Jupiter's. These examples show how rotation can give planets a unique shape. They go from being perfectly round to having a delightful bulge around the middle. It's like cosmic pottery, where the spinning motion creates a playful and distinct shape. So now you know why the planets are round. But what's more interesting is, what if they weren't? What if they were, let's say, cubical? Or even triangular? Well, let's see. A cube-shaped or a triangle-shaped planet would have its mass spread out in a completely different way than a sphere. And you know what that means? Gravity would be all shook up too. On a spherical planet, gravity pulls everything towards the center because the mass is evenly distributed around that center. But when we introduce a cube-shaped or triangle-shaped planet, things get interesting. If you're standing at the center of one of those faces, you'd feel the strongest pull of gravity. That's because the faces are the closest to the center of gravity. And as you venture away from the center and start walking towards the edges, gravity starts playing tricks on you. You would feel the struggle against the steep-angled gravity. Walking on those edges would feel just like climbing a mountain, or walking on a super steep slope. All because gravity wants you right in the middle of the face, and nowhere else. Now imagine the terrain along the edges and corners. It's a barren, rocky, and dry landscape. Why? Well, all the water would pool in at the center of each face, leaving the edges high and dry. And the air quality? Well, it's either non-existent or so thin that it can't support life. Not the coziest place to set up camp, that's for sure. And don't forget your warm clothes, lunch, and hiking boots. You'll need them because of the crazy climate. The type of climate you'll encounter on our cube or triangle-shaped Earth depends on how it spins. If it rotates at its corners, each side would enjoy a mild, temperate climate. However, if it rotates on an axis through two of its faces, things get intense. Picture a roller coaster version of our current climate. Some faces would be polar wonderlands, icy and chilly. The top and bottom faces for the cube, and the bottom face for the triangle. Meanwhile, the other sides would be completely different. In a cube, they would be scorching hot with an equatorial climate that would make you break a sweat. Instead of sunlight gently curving along the surface, it would directly beam onto these faces. Talk about feeling the heat. And on a triangular planet, the sunlight would strike the faces at an angle. This angled sunlight would create fascinating temperature variations across the planet. Imagine this. As you move from the base of the triangle towards the tip, the temperatures would gradually decrease. The base, where the sunlight hits most directly, would be the hottest region, just like the equatorial climate we're familiar with on our spherical Earth. But as you venture towards the tip, the angle of sunlight would be less direct, leading to cooler temperatures. But the base is still super cold and dark, since the sunlight doesn't directly reach it. So the triangle would be absolutely crazy in terms of temperature changes and climate zones. By the way, you know that cozy blanket of air we call the atmosphere? Well, on our angular Earth, things would get a little topsy-turvy. Gravity would be pulling stronger from the center of each face. The result? The atmosphere would go through some crazy changes. Picture this. At the center of each face, where gravity is strongest, the atmosphere would gather and thicken. It would be like a bustling city, full of air molecules. But as you venture towards the edges, things would start to thin out. The atmosphere would become scarce and very thin. So breathing along the edges would be quite a challenge, and the edges would be a tough neighborhood for life to thrive. Moreover, a thinner atmosphere means less protection from the sun's radiation and solar winds, so corners and edges would be extremely dangerous for humans. Of course, this is all just a playful exploration of what could be. Our Earth loves its spherical shape, and that's a good thing. But there's no harm in imagining wild and wonderful possibilities, so keep your imagination soaring and continue to marvel at the marvels of our amazing planet, however it may be shaped.
The hunt for interesting exoplanets and life forms somewhere out there in the vast expanse of the universe keeps going. No stopping here. We're basically searching for a second Earth, a planet that's similar to our home, and where we could finally find some space friends. Hey, we're not picky. Any form of life is fine, even some bacteria-sized organisms. And this search has mostly been going on in the habitable zone around other stars. We call this the Goldilocks zone. That's a region where conditions are barely just right for liquid water to exist, whether we're talking about the surface of a planet or a moon. The hotter the star, the more space we get to explore, because its habitable zone spreads far away. And in terms of endless space that we yet know so little about, that's a lot of work. That's why we're fans of red dwarfs. There are hundreds of billions of stars in our galaxy, and probably around 80% of them are red dwarfs. These tiny stars are much cooler than our Sun. It means that their habitable zones are much smaller and closer to the star, so we know better where to look for planets. They're circling around their central star, and at some point, bingo, there it is. They pass in front of it and block out some of its light. The Kepler Space Telescope has already helped us find thousands of planets using this method, and most of them are orbiting around red dwarfs. Some of these planets are similar in size to Earth, and many of them could have nearly 25 times more water than our entire planet. Let's move to these planets scientists discovered, though. I want to show you something special. So, you've heard of super-Earths, right? More massive than Earth, lighter than Neptune, can be made of rock, gas, or a mix of both. Some of them have thick atmospheres, while others have thin or no atmospheres at all. You may also have stumbled upon mini Neptunes by now, too. They're almost as big as Neptune, and unlike normal gas giants, they have solid cores. That way, they can support a dense atmosphere with water and some other chemicals necessary for life. There's also hot Jupiters. Those are pretty cool, but only if they're far away from us. You know that one annoying and unpredictable neighbor you can never get rid of or figure out what they're going to do? Yeah, that would be a hot Jupiter, with strong gravity that can destabilize the orbits of smaller planets or other space bodies in the system. If we had such a neighbor, there would be more comets and asteroids hitting our surface. Luckily, our Jupiter's a good and peaceful neighbor that minds his own business, at least for now. But let's leave all these and many other planets out there alone now. Imagine traveling around in your spaceship and coming across a giant eyeball just floating there in the darkness of space and staring at the central star of that solar system. It's not a monster. Hopefully, space friends we'll make in the future won't look that big and scary, so it won't blink or turn towards you as you come closer. It's actually a planet. A little bit bizarre, but still very cool. And yup, you guessed it right, we call such eyeball planets. Now, eyeball planets are surprisingly common. Plus, some normal planets can potentially turn into them too. Eyeball planets form when matter and dust accumulates around a star and gradually turns into a solid object. It starts spinning, and over time, the gravity of the star pulls on the planet and slows its rotation until it becomes tidally locked. That means one hemisphere always faces the star, while the other is in darkness all the time. Now, we have a good example of this phenomenon near us, too. Our moon makes a circle around Earth once a month. It takes the same amount of time to turn a single time on its axis. That way, we actually always see the same face of the moon. Who knows, maybe the other side is even prettier, if you like craters and stuff. So one of the most interesting things about eyeball planets is their appearance. If they had water on their surface, the side facing the star would have clear, bright blue oceans, the ones we'd want to visit if we ever got a chance to go on an interstellar vacation. And the other side would be more for adventurers who like harsh and challenging surroundings. Since it's in constant darkness, it would most likely be very cold and covered in ice. We've discovered so many planets outside of our solar system in the last 30 years. Super-Earths are, of course, especially interesting. It seems that many of them are not that pleasant, since they're pretty hazy and cloudy. It means it's harder to spot any life there. But some scientists still think they're promising spots when it comes to finding life beyond our solar system. Eyeball super-Earths would be a good start. These planets are probably covered in large oceans. On the cold half, where the eternal night reigns, you'd experience Arctic conditions. I feel cold just looking at this. But the day side is my jam. Plus, it sounds promising when it comes to finding life. With all that sunlight, oceans, and stuff. One of the good examples where scientists are looking for life is an eyeball super-Earth that lies in a habitable zone of the closest star to our solar system, called Proxima B. Its day side could even have conditions and an atmosphere to support some form of life. There could be a large deep ocean covering its surface. It could be really salty, but some forms of life could still survive there. Check out the Dead Sea on Earth. It's extremely salty, but some bacteria have still evolved to live there. And they're probably doing well, having their own world and all that. It's not crowded because there are no animals there. Fish that accidentally end up in the Dead Sea won't survive there for long. So, similarly, it's possible that bacteria or some other forms of life could exist in this potentially very salty ocean on Proxima B as well. But the open ocean on Proxima B could be tricky. On the dark side of the planet, the ocean could freeze, and sea ice could drift into warmer waters. That way, the ocean would cool, and more of it would freeze, even on the sunny side. The only way to prevent this global freeze-over would be an atmosphere with a lot of greenhouse gases like carbon dioxide. This kind of atmosphere would trap the heat from the planet's surface and wouldn't allow it to escape into space, like what happens with Venus, the hottest planet in our solar system. Without an atmosphere with greenhouse gases, the surface of Proxima B would be much colder, so it's possible that the planet would completely freeze over. The opposite scenario could also be possible. Warmer waters could serve as a transporter of heat from warm to cold regions. We don't know much about the conditions on the planet yet, so Proxima B could range from a frozen wasteland to a hot, hazy world, depending on many factors. So yeah, an eyeball planet within the habitable zone sounds promising, but its surface can still wildly range from a frozen desert to an endless ocean. Some experts believe that drifting sea ice might cool many exoplanets out there, and they can't turn into eyeball worlds. Instead, many just become sad, dark snowballs, completely covered in ice. A cool spot to spend your interstellar winter holidays, but not a place where you'd hope to find life, unfortunately. Some studies show that even Earth may have gone through some snowball stages many times in history. One of those happened around 2.2 billion years ago. I wasn't around. While the other one hit the planet 630 million years ago. During these phases, all of our beautiful oceans were covered with snow and sea ice. Perhaps even the continents were just thick ice sheets, at least on the surface. Alright, enough with the freezy icy stuff. I need some hot chocolate.
Uranus is an enigmatic giant that has puzzled astronomers for centuries. But what sets this gas giant apart from the others is its strange tilt. While most planets spin on an axis that is perpendicular to their orbit, Uranus takes a wild spin in a different direction. But why does it look like this? How did the planet turn out to be lying on its side? And what would we see if we visited the surface of such a planet? Let's find out. Uranus, the seventh planet from the Sun, is a cosmic oddball and source of many jokes. It's one of the gas giants in our solar system, along with Jupiter, Saturn, and Neptune. It's also the third largest planet in our solar system, with a diameter of about 31,000 miles. And one of its many oddities is a weird rotation on its side. Not all planets in our solar system are aligned in a straight line. While most planets in our solar system have an axial tilt of less than 30 degrees, Uranus is tilted at an angle of almost 98 degrees. It's like that one friend who always has to be different, even if it means standing on their head to prove a point. So its north and south poles are facing east and west. It's like the planet got lazy and just rolled over one day, deciding to take a nap. And why is Uranus so tilted, you ask? Scientists once thought this was due to some kind of collision. They thought that something gigantic crashed into Uranus, something like what happened to our Earth. A dwarf planet crashed into it, the Earth tilted slightly, and the Moon was born from the remnants of the collision. But this theory had a problem. In the early universe, there were a bunch of asteroids, dwarf planets, and other large objects. And if this is so, then why is only Uranus tilted? All sorts of guys have crashed into other planets too, but they don't have such features. But recently, scientists have published a new study, and now scientists think that the culprit might be a long-lost moon that wandered away. Back in the days of the early solar system, the giant planets partied much closer together and way closer to the sun. But, as we all know, parties can get out of hand. Something caused Uranus and Neptune to migrate the farthest, like they were trying to get away from the sun's strict supervision. Each giant planet had a collection of moons, but they were constantly getting shuffled around during all this migration madness. Some planets lost moons, while others gained new ones. Uranus could have been born with a massive moon, or quickly captured one. And if that moon was big enough, it could have started playing games with Uranus's spin. This moon pulled on Uranus with its gravity, making the wobbling even worse. As time went on, it made Uranus tilt more and more. Eventually, it crashed into the planet, locking it into its current tilt. While the theory is pretty sound, based on computer models, we'll have to wait until at least 2030. That's when China plans to launch the Tianwen-4 spacecraft to take a closer look at Uranus and study it more. Who knows what other crazy space secrets we'll uncover next? Until then, we can all have a good laugh about the lazy, rebel planet that just can't seem to stand up straight. Such a funny and unique feature makes you wonder, what exactly would we see if we were standing on this planet? How would its strange tilt affect the view from its surface? Let's see. If you were standing on the surface of Uranus, although it doesn't really have a surface, it's more like a gas atmosphere, you'd enjoy a cool view. You'd see the sun rise in the east, just like on Earth, but then it would keep going around the sky in a tilted path, like a lazy spiral. About the sunset, though, I hope you have some patience, because it would take 42 years for the sun to complete one full circle around Uranus's sky. That's a really long time to wait before finally going to bed. But speaking of the sky, it would be a beautiful sight to behold. Uranus is known for its stunning, unique blue-green color. It's caused by the methane gas in its atmosphere. Methane absorbs red light, giving Uranus its cold hue. You'd also see some amazing clouds and storms swirling around the planet. But if you're looking for constellations, you're out of luck. The extreme tilt of Uranus means that its poles face towards the sun, so the stars would be all over the place in the sky. The constellations that are familiar to us would be unrecognizable from Uranus. Also, as the planet rotates, the position of the stars would change very often. For you sailors out there, good luck in navigation. But you could see its beautiful moons. Uranus has 27 known moons, with the largest being Titania, followed by Oberon, Umbriel, Ariel, and Miranda. These moons are thought to have formed from the same material that formed Uranus, and yes, the tilt affects them too. They orbit around the planet perpendicular to the planet's motion around the sun. And they aren't the only ones. Did you know that Uranus also has rings? Yeah, not only Saturn is so special. The rings are made up of ice particles, some as small as grains of sand, and others as large as several feet across. They're thin, narrow, and dark compared to Saturn, for example. They're actually so black that they almost don't reflect the light. That's why it's so difficult to see them from Earth. But if you were near the surface of Uranus, you might be able to see them in the sky. The only question is, would you even be able to focus on all these views? Because Uranus is extremely cold, and that will probably be the only thing you'd think about. We're talking about temperatures that can drop down to negative 350 degrees Fahrenheit. Brr, better pack some warm clothes for this trip. This is because it's so far from the sun, and its atmosphere is composed mainly of hydrogen and helium. And not only is Uranus the coldest planet in our solar system, but the winters there are long. Due to the extreme tilt, it has seasons that last for over 20 years. It's like the planet is stuck in a perpetual state of winter, which is both cool, pun intended, and kind of sad at the same time. And if that's not cold enough, Uranus is also known for its strong winds. In fact, they can blow up to 360 miles per hour. So you might want to hold on tight to something, or wear a windproof suit to avoid being blown away like a leaf. And finally, Uranus's magnetic field is also tilted at an angle of 59 degrees from the planet's axis of rotation. This creates some interesting effects. The most obvious one is beautiful auroras, which are similar to the northern and southern lights on Earth. On Uranus, however, the auroras are located near the planet's equator rather than at the poles. Isn't that cool? The result is a dazzling light show that would make even the most jaded space traveler stop and stare in wonder. But even though it sounds pretty awesome, it makes it more difficult for spacecraft to navigate around Uranus. The magnetic field creates a lopsided gravitational pull that can affect the trajectory of spacecraft. This makes exploring Uranus a bit more challenging, but maybe it will change in the future. All in all, standing on Uranus would be a chilly, wobbly, and breathtaking experience, and definitely not your average stroll in the park. Next time you look up at the night sky, think of this beautiful icy planet, and remember that even in the vast expanse of space, there is always something new and exciting to discover. In a star system far, far away, to be more precise, 2,600 light years away, there's an exoplanet called Kepler 1658b. It's a gas giant that resembles our Jupiter. But what differentiates it from Jupiter is that this poor planet is doomed. It's spiraling toward its parent star, which will eventually end in a fiery collision. But the most interesting thing? Astronomers would have remained totally ignorant of this fact, if not for a tiny clue. It was a really minuscule change in the planet's orbit. It wouldn't have been noticed if astronomers hadn't compared more than a decade of data received by different telescopes. More precisely, scientists have been watching the exo-Jupiter pass between our planet and its parent star once every 2 weeks for the last 13 years. And they've noticed that the orbit of the planet is getting smaller and smaller. Every year, Kepler 1658b needs 131 milliseconds less to complete a lap around its star. If this tendency continues, the planet is bound to collide with its star in 2.5 million years. Even before this discovery, computer models predicted that some planets could meet their end by crashing into their stars. But this is the first time when astronomers have some real proof of such an outcome by measuring almost imperceptible changes in a planet's orbit. They now know for sure what happens when a planet is going to crash into its star, even though we probably won't be around to witness it. But let me tell you a bit more about the doomed planet. It was discovered by NASA's now retired Kepler Space Telescope. It was launched in 2009, and its mission was to find planets orbiting other stars, aka exoplanets. And the very first exoplanet the telescope spotted was the very gas giant we've been talking about. But it took astronomers about a decade to confirm that this space object was indeed an exoplanet. This world is like a denser version of Jupiter. I mean, take 6 Jupiters worth of material, roll it into a ball about 1.1 times as wide, and voila! The planet is tidally locked to its parent star, which means that it makes one complete turn every time it finishes a lap around the star. As a result, the same side of the gas giant is always facing the star. It's the same as what happens to the moon. Our natural satellite is tidally locked to Earth. That's why we only see half its surface. Now, what is making the exo-Jupiter fall into its star? The same process that is pushing the moon away from Earth. When a moon orbits a planet, or a planet orbits a star, their gravity forces interact and tug on the other's mass. That's what causes tides on Earth. This tugging releases some energy. It can make an object speed up and slow down. In the first case, a space body will move higher. In the second, it will start moving lower. And this is exactly what's happening to the gas giant. Its parent star is 1.5 times the mass of the Sun. So, no wonder its tidal forces are gradually slowing down the planet's movement, making it fall inward. This all sounds kind of tragic, but this potential collision is by far not the weirdest thing happening in space. Let's look at some others. For example, Betelgeuse, a red giant in the Orion constellation, started to dim in 2019. This confused astronomers. By that time, the star had already swollen to enormous proportions. If it was to replace our Sun, its outer surface would spread far beyond Jupiter's orbit. And then Betelgeuse became dimmer in the fall of 2019. This process continued through February 2020. The changes could be seen with the unaided eye. No wonder, the star's brightness had dipped by 2/3. At that time, astronomers were sure Betelgeuse was about to explode into a supernova. They continued to observe the star, but unexpectedly, it returned to its regular brightness. Thanks to the Hubble Space Telescope, scientists figured out that the star had ejected some of its material, and this partially blocked its light. How about cotton candy exoplanets? Those are particular planets outside of our solar system. Also called superpuffs, they have the lowest density ever discovered. This gives them an airy, fluffy appearance. But despite looking like the most popular amusement park treat, such planets are enormous. Come to think of it, scientists often discover strange things in space. Some of them look like blurry blobs. But there's one type of these blobs that doesn't look like any other known space body. The odd radio circles are only visible in radio telescopes. They might be the remains of supernovae, but some astronomers go as far as to claim that they might be the throats of wormholes. Those are hypothetical tunnels between two very distant points in space. The Juno mission noticed something weird in the upper atmosphere of Jupiter. The unusual phenomenon was blue sprites and elves twirling above the planet's surface. These are two kinds of bright flashes of light that appear for short periods of time, mere milliseconds. They extend up and down toward the surface of the planet. On Earth, such flashes usually happen at the height of 60 miles above massive thunderstorms. Rogue planets don't orbit their stars, maybe because they don't have any. These free-floating space bodies travel across the universe and can end up literally anywhere. They're also pretty hard to find. rogue planets produce only weak emissions. But not so long ago, astronomers spotted the smallest rogue planet in the Milky Way. It's smaller than Earth, but a bit bigger than Mars. Fast radio bursts are blindingly bright bursts of radio waves. They pack as much energy as our sun produces in days, but last mere milliseconds. Most of these fast radio bursts come from far, far beyond the Milky Way. But recently, astronomers have detected some originating in our home galaxy, and their source is a magnetar just 30,000 light-years away from our planet. If it does exist, nuclear pasta is the strongest material in the entire universe. Formed from the leftovers of extinguished stars, this substance gets squeezed into spaghetti-like tangles of material. It can break, but only if you apply 10 billion times the pressure needed to shatter steel. Not so long ago, scientists discovered that one of the most massive stars in the neighborhood had just disappeared. It was a star 75 million light-years away from Earth. Normally, it'd be too far away for astronomers to clearly see individual stars, but only unless they're huge. And the star we're talking about was enormous. It was shining 2.5 million times brighter than the sun. For the last time, astronomers saw the star in 2011. They decided to examine it more closely several years later, but it was already too late. The star had vanished. Such massive stars usually go out in extremely bright supernovae, but astronomers noticed nothing like that in this case. There's a theory that the star collapsed into a black hole without triggering a supernova first. It does occur among stars approaching the end of their lives, but very, very rarely. There are black holes, and there might be mini black holes, even though their existence hasn't been proven yet. Unlike their massive siblings, hypothetical mini black holes could be really tiny, not bigger than an atom. Their mass can vary, but just one minuscule thing might have the mass of 1,000 sedans. One theory claims that tons of micro black holes could have been created right after the Big Bang and the beginning of the universe. Some scientists even go as far as to say that a couple of mini black holes pass through our planet every day. More than 7,000 light-years away from Earth, there is the Eagle Nebula, a young cluster of stars just 5.5 million years old. The Hubble Space Telescope managed to take an image of several dark silhouettes near the nebula's center. Those are the so-called Pillars of Creation, an active star-forming region. Look, how cool is that?
Jupiter is the largest planet in the solar system. More than 1,300 Earths could fit inside this gas giant. It's also 2.5 times more massive than all the other planets of the solar system combined. But if you think this is mind-boggling, I've got some great news for you. Very recently, a team of astronomers have discovered a much, much bigger planet with the help of the Subaru telescope and the NASA Hubble Space Telescope. It's a Jupiter-like protoplanet orbiting a very young star, AB Aurigae. The star is probably still forming and is no more than 5 million years old. For comparison, our Sun is 4.6 billion years old. The young star is located at around 531 light-years away from Earth in the constellation of Aurigae. The star is shrouded in a thick, quickly moving layer of gas and dust. This disk feeds the growth of the star. Later, what's left of the disk will come together to form the elements of the planetary system. Planets, dwarf planets, comets, asteroids, you name it. But back to the newly discovered planet. It's a gas giant whose mass equals that of 9 Jupiters. Can you imagine this colossus? It takes the planet, named AB Aurigae B, almost 588 Earth years to complete just one journey around its parent star. Maybe because it's 93.9 AU, astronomical units, away from it. Now, why is the discovery of this planet so amazing? Because according to astronomers, it's been forming in a very bizarre way. Or should I say, is forming, since this gas giant is still in the process. Anyway, The unusual thing is that AB Aurigae B is coming together as a result of a top-down gravitational collapse of giant clouds of gas. But scientists say that a much more common model of planetary formation is when dust and rocks gradually accumulate around some kind of core. This proves the idea that there are numerous ways for planets to form. It can also mean that there probably are very diverse planetary systems in our home Milky Way galaxy. But AB Aurigae B isn't the largest exoplanet ever discovered. In 2005, astronomers spotted a mysterious space body. Later, they called it GQ Lumpy B. The thing was orbiting a young star at a distance 2.5 times greater than that between the Sun and Pluto. Scientists came to the conclusion that the object was either a planet or a brown dwarf, which is basically a tiny star. If astronomers decide that GQ Lumpy B is a planet, it will be the largest ever found, with a radius that is 3.5 times that of Jupiter. The biggest star we know about is called UY Scuti. This hypergiant has a radius that is about 1,700 times greater than that of the Sun. If you somehow manage to place UY Scuti in the center of the solar system, its edges would stretch far beyond Jupiter's orbit. As for the dust and gas streaming from the star, all this would extend beyond the orbit of Pluto. That's 400 times the Sun-Earth distance. A black hole is a spot in space where the pull of gravity is so strong that even light can't escape it. But why is gravity so powerful there? Because matter is squeezed into a teeny tiny space. Supermassive black holes, which can be many millions of times the mass of the Sun, tend to lurk in the centers of galaxies. The most massive black hole astronomers have discovered so far is TON 618. Its mass is equal to that of 66 billion suns. It was the year 2010. With the help of the Fermi telescope, astronomers spotted something ginormous, something entering the Milky Way. Their discovery looked like massive blobs of matter that could only be observed in particular wavelengths of light. They were also about 25,000 light-years tall. Scientists think that the blobs, called Fermi bubbles, could be produced by our galaxy's central black hole. Space seems to be extremely deserted, but some places are even emptier than the rest, like supervoid in Uranus. Astronomers noticed this huge region of empty space in 2004. The area stretches 1.8 billion light-years across. It's mysteriously devoid of gas, dust, stars, and even dark matter. A nebula is a massive cloud of gas and dust floating in space. Some nebulae form when a star is nearing the end of its life and throws out loads of gas and dust. Others appear in regions where new stars are forming. The largest nebula we know about is the Tarantula Nebula. In its longest span, it measures over 1,800 light-years. This nebula, also known as 30 Doradus, is located around 170,000 light-years away from Earth. Unlike its namesake, the tarantula isn't dangerous. Quite the opposite. It's a stellar nursery, which means it's a region where tons of young stars are born. Even cooler, it's the most active star-forming area in our entire galactic neighborhood. In 2021, the biggest ever comet we know about entered our solar system. It was 85 miles across, and its icy nucleus was 50 times greater than the nucleus of the previous record breaker. The intruder's mass was a whopping 100,000 times bigger than that of the average comet. In fact, see 2014 UN 271, Bernardinelli-Bernstein, was so large that astronomers first classified it as a minor planet. Is it going to crash into Earth? Nah. It won't get closer than 1 billion miles to our beautiful green planet, and it won't happen until 2031. But could there be comets even bigger than that? Who knows, but the thought is terrifying. There are loads of bizarre things in the universe, and hypothetical nuclear pasta is one of them. If it does exist, nuclear pasta is the strongest material in the entire universe. It forms from the leftovers of extinguished stars when this substance gets squeezed into spaghetti-like tangles of material. It can theoretically break, but only if you apply 10 billion times the pressure needed to shatter steel. Pulsars are spherical space objects the size of a large city, but they pack more mass than the entire sun. They radiate two narrow beams of light, sending them in opposite directions. The Black Widow pulsar, just like its spider namesake, is munching on its partner. It's a lightweight brown dwarf star. The more material the pulsar consumes, the more slowly it spins. The energy the neutron star is losing in the process causes its companion star to dwindle. Haumea is a dwarf planet orbiting the Kuiper belt. It's a donut-shaped ring of objects around the Sun that extends just beyond the orbit of Neptune. The mini-planet has a bizarre, elongated shape and 2 moons. The day on this planet lasts just 4 hours, which makes it the fastest spinning large object in the solar system. But the most mysterious thing about Haumea is that the planet has a thin, 40-mile-wide ring circling it. What is it? Where did it come from? No one knows. Could be the result of a collision that happened in the distant past. The 18th brightest star in the night sky, Fomalhaut, is a terrifying sight. It's dubbed the Eye of Sauron because it looks like a ring of dust and debris circling it. It makes the star look like a giant eye staring into your soul. The intimidating star is more than twice the mass of the Sun. It's 25 light-years away from Earth, which isn't that far away considering distances in space. Look at this butterfly. Its wingspan is more than 3 light-years. And the structure inside this nebula is one of the most complicated ever observed. The nebula's central star, a white dwarf, is heated to an incredible 450,000 degrees Fahrenheit. It means it was formed from another gargantuan star, more than 5 times the size of the Sun. The white dwarf is surrounded by a thick disk of dust and gas at the equator. That's what probably makes the whole structure look like an hourglass or a butterfly.
The only life that we are certain about so far in the entire universe is on planet Earth. Whether that life is intelligent is, let's say, arguable. But anyway, it's not surprising that we're tirelessly searching for life on other planets. So far, they've discovered more than 4,000 of them. But what's even cooler? NASA has compiled a new list of 24 planets that aren't just Earth-like, they're better. The conditions on them are so good that they're more comfortable than on our planet. So let's examine some of them. KOI 5715.01. Let's be coy, shall we? This wonderful planet is in the constellation Cygnus. And why is it so wonderful? Well, our Sun is a yellow dwarf. And sorry, Sun, even though you're not bad at supporting life, there are some stars that can do it better. Nothing personal. The planet KOI 5715.01 orbits near an orange dwarf. Orange dwarfs are stars slightly smaller than our Sun and have a little lower luminosity. Did you like the alliteration there? Anyway, don't worry, it doesn't mean we're going to live in complete darkness. In fact, if the planet is found closer to the Sun and it has a thicker atmosphere, it may even be lighter and more colorful than on Earth. Now, our Sun has a very short lifespan. Right now, it has 7 to 8 billion years left to live, a little longer than Earth's age. But orange dwarfs can live from 45 to 70 billion years. This is great not only because we'll be able to hang out on this planet longer, but also because the planets around these stars have more time to form life. Now, ideally, we would need to find a planet next to an orange dwarf that is about 7 billion years old. It's very likely there will be at least some organisms there. Koi 571501 is about 5.5 billion years old. Yeah, it may not seem mature enough, but that's okay, neither do I. Our Earth is a billion years younger, and that didn't stop us. The planet is quite close to its star and is in a habitable zone. 1 year there lasts 190 days. Imagine going to elementary school and already getting a driver's license. It's almost 2 times larger than the Earth. The average temperature there is 52 degrees Fahrenheit, which is slightly less than ours, 57. But it mostly feels warmer there because strong gravity helps it hold on to heat in the atmosphere longer. It's a little too far away though, like 3,000 light-years from Earth, which is about 18 quadrillion miles. Yep, better bring a really big lunch with you. Koi 3010.01. This planet is found next to the star Koi 2010. This planet sounds like a very pleasant world. The average temperature on this planet is 67 degrees, so a little warmer than ours, but that's a good thing. Scientists believe that on a perfect planet, the temperature should be just about 10 degrees hotter than on Earth. The more heat there is on the planet, the more comfortable it is to live there. Also, the higher chances of developing life. The radius of this planet is nearly 1.5 times larger than Earth. There's some atmosphere, although we're not yet sure about its composition, but it's probably like the Earth's. Scientists think that we'll find an ocean there, and it can cover up to 60% of the surface, which is also cool. In a perfect world, water and land should be distributed more evenly than on our planet. A little more land means a little more territory and resources, right? But listen, this planet is actually very similar to the Earth. The semblance is so striking that scientists believe we have an 84% chance to find life there. Of course, not necessarily an intelligent life, but at least some animals. Wouldn't that be cool? Now, what do you think they could look like? Very Earth-like planet, but with stronger gravity. Well, if someone lives there, they're probably big but have a small height and strong little legs. Sounds adorable and scary. But we won't be able to find out the truth anytime soon. So far, for us, these planets are microscopic dots in space. We only have some dry, boring data about them and don't even know what they look like. We'll have to wait until we can find a way to get closer to these planets. Kepler 186f. This is also one of the best candidates for having life. This rather cute planet was nicknamed the Earth's cousin because it does have a strong resemblance. Anyway, these two planets are like sisters, not twins. Kepler 186f rotates near a red dwarf. Red dwarfs are stars even dimmer and smaller than orange dwarfs. Yeah, they'll also live for a very, very long time, but their luminosity is also quite low. However, Kepler 186f is closer to its star than we're to our Sun, so it shouldn't be too dark there. Well, at least not night-like dark. The sky on this planet is sure to be an unusual shade of red, like sunsets on Earth. What do you think? Would you like to live on a planet with an eternal sunset? The size of this planet is about the same as Earth. Not bad, not perfect. Why so? Because the coolest planets are those that are bigger than Earth and have stronger gravity. Now you'll probably say, but wouldn't it be harder to walk there and even harder to get out of bed on Monday? Of course. But on the other hand, this planet will pull the atmosphere better. The atmosphere will be thicker and denser. This means more protection from the scary space stuff, more oxygen, and more heat. Not to mention the fact that the bigger planets have more space to settle. Awesome, right? But of course, the Earth's size is also an excellent choice. Another cool fact is that the tilt of Kepler 186f is about the same as ours. It means that there should be stable seasons and a normal day-night cycle. Do you know how important the tilt of the planet is? Let's look at Mars. Mars is also, in fact, found in the habitable zone of our Sun, but its tilt is very unstable, and as a result, the entire ocean that could have been on it once now completely dried up. Today, it's just a red desert, and there's no life there. At least not as far as we know, but you see how important these tiny details are? This planet is also quite far away from us, 490 light-years. That's about 3 quadrillion miles. So yeah, we're just going to keep waiting for intergalactic travel. Kepler 62e and 62f. These planets were called the most Earth-like before we discovered Kepler 186f. They're very comparable to our home. Kepler 62e is about 1.5 times larger than Earth, and Kepler 62f is just slightly smaller than that. They're located in the constellation Lyra, which is about 1,200 light-years away from us. They both also orbit a red dwarf. 1 year on Kepler 62e lasts about 122 days, even less than on that first planet we talked about. Scientists believe that both 62e and 62f are sort of water worlds, warm places mostly, or even completely covered with water. If there is land there, it's probably just some islands. A world consisting entirely of islands. A fantasy dream for some, think Hawaii, and a nightmare for others, think Megalodon. But if you're a fan of ancient marine animals, just imagine how gigantic they could be there. Still, there are many things we don't know about this planet. Does it have a surface? What about its composition, density? One day, maybe we'll be able to answer these questions. And so, that's it for the super-Earths. Of course, the original list is much longer, and you can go check it out on the internet. Now, the best thing about all this is that these are planets that are better than the Earth. But we also know thousands of other exoplanets that are just close enough to ours. And the odds are, a few of them have at least some form of life. But they're very, very far away, so we have no way to check it out right now. Perhaps, down the road, we'll find some cool creatures on many of them.